here's a fun problem. The limit as x goes to 0 of x to the x power dl. That's kind of interesting because see if the base is 0, 0 to any power is 0. But if the exponent is 0, well, anything to the 0 power is 1. So what's like, what is this? 0 to the 0, what does that mean? Well, anyway, it is undefined, but we're going to find, that's the beauty of calculus. We don't care if it's undefined. We're still going to find the limit as x approaches 0. That's in my opinion what makes calculus great, is that, or I should say plucky, that even if something is, quote, impossible, I'm doing air quotes now, but you can't see them. Here I am, this is me doing air quotes. Even though something is technically impossible, but in calculus we say, okay, fine. Maybe it's impossible to plug in 0, but we could still find the limit as x approaches 0. Anyway, the way we do this, we're going to handle this with logarithms. We're going to say that the ln of L is equal to the ln of x to the x, of the limit of x to the x, and but the ln of x to the x by exponent laws is x times ln x. And the limit is x goes, I forgot to write the limits I wrote over here on the side. This limit actually only applies to the x ln x. It doesn't really apply to the ln L because ln L doesn't have an x in it. Anyway, but I talk too much. Let's move on. So how do you deal with this? We're going to take x ln x and rewrite it as x over 1 over x. Why did I do that? Because now I can use L'Hopital. That's LH, L'Hopital. And L'Hopital says take the derivative of the top, derivative of the bottom. So the derivative of the top is 1 over x. The derivative of the bottom is negative 1 over x squared. If I simplify that, that just comes out to, this fraction just comes out to negative x. And the limit is x goes to 0 of negative x. Well, that's just 0. So that means that ln L is equal to 0, which means L equals 1. So the limit as x goes to 0 of x to the x is actually 1. Pretty awesome. Let's do a similar question. This question is very, very similar. It's the limit as x goes to 0 of 3x raised to the 2x power. I'm going to do the exact same things. I'm going to take the ln of each side. Now the ln L is equal to the limit as x goes to 0 of the ln of 3x to the 2x, but rules of exponents says I could take the 2x and bring it out front. Now, notice I did something very, very sneaky. But you're allowed to do it. Really, I took the ln of L is the ln of this thing, meaning it's the ln of the limit. But what I did is I put the ln inside. I wrote here the limit of the ln, when in reality I did the ln of the limit. Well, we learned a theorem that says that limits can be taken in and out of functions, and this is perfectly permissible. And that's very important, very, very important theorem. Anyway, this is equal to the limit as x goes to 0 of ln of 3x over 1 over 2x. Again, I wanted to write this in a form where it's a fraction and the top, as you can see, is going to infinity, or I should say negative infinity. The bottom is going to infinity. So you have an infinity over infinity type situation, which means L'Hopital's rule is applicable. And this is going to be equal to the derivative of 3x is 1 over x. And the derivative of 1 over 2x is negative 1 over 2x squared. By the way, on the top, I have 1 over x. I'll leave it to you to figure out what happened to that 3. How come that 3 just disappeared when I took the derivative? Anyway, but that's your side chat. That's something you should figure out if you haven't figured it out already. Anyway, extra challenge. Anyway, once I simplify this fraction, it just becomes negative 2x. The limit as x goes to 0 of negative 2x is equal to 0. Hence, ln L equals 0. Hence, L, the limit, is equal to 1. So the limit as x goes to 0 of 3x to the 2x power is equal to 1. And that is awesome.